In this lesson, we will answer the questions about the section, models of the atom. Question number 1. Which type of spectrum is used to identify elements in the atmosphere of a gas? So if we are going to define the elements in the atmosphere of the gas, it's going to be used absorption spectrum, because the light produced at the center of the star, which is a continuous spectrum, passes through the gases in the atmosphere, and then some photons are trapped, absorbed by these gases, and the position of those absorbed photons appears dark in that continuous spectrum, which is called absorption spectrum. Question number 2. Which of the following summarizes Thomson's model of atom? Atom's hard, uniform, indestructible sphere. Not this one. This is in the time of Isaac Newton. It was defined this way. Choice B. Electrons are embedded in a sphere of positive charges. So this is the correct one. Electrons are embedded in the sphere of positive charges. Electrons orbit this nucleus in the same way orbit sun. This is the Rutherford's model. Electron exists only at discrete energy levels. This is the Bohr's model. Question number 3. The explanation of the aurora borealis, which is northern lights, is provided by which of the following samples? Bohr's model can explain that, because the gas are shining and then emitting different wavelength of the light is first explained by Bohr's model. Question number 4. What happens when an electron moves from a higher energy level to a lower energy level in an atom? From higher to lower energy level, when the electrons are transiting from higher to lower, so this difference in energy of these levels are emitted as photon. So according to Bohr's model, energy is absorbed from the source outside the star. No, this is not the case. If it is this case, electron must move from lower energy level to higher one. Energy contained in the electromagnetic field inside an atom, it increases. Not this one. Energy is released across a continuous range of the values. Not continuous, because jump is done between some certain energy levels. A photon is emitted with an energy equal to the difference in energy between the two levels. This is the correct answer. So the difference between the energy levels is going to be energy of the photon. Question number 5. Bohr's model was unsuccessful to explain which of the following? A lot of properties of hydrogen spectrum. It's explained. The hydrogen-like atoms. Hydrogen energy level predictions. Yes, it's predicted. These two are not unsuccessful. Successful they are. To be applied to hydrogen-like atoms, correct. It applied to the hydrogen-like atoms. So all these three are correct, but we are looking at unsuccessful one. To be applied to the atoms that contains more than one electron. So this is the correct answer of this question, because Bohr's model couldn't explain the behavior of atoms which have more than one electrons. Question number 6. What type of spectrum is created by applying a high potential difference to a pure atomic gas? So when you apply a pure atomic gas, electrons of this gas excites to higher energy levels, then transits to the ground state or lower energy levels by emitting photon, which is called emission spectrum. So an emission spectrum. An electron in a hydrogen atom drops from energy level of E4 to energy level of E2. What is the energy of the emitted photon? So this is the initial energy level, which is higher. This is final energy level, which is lower. So energy of the photon will be initial minus final energy levels. So E initial minus E final. Final energy level lower than initial. So initial energy level is E4, which is negative 0.85 minus final is negative 3.4. This negative is the equation's negative. This is the number's negative. Negative 3.4. So we will use the calculator. Negative 0.85 negative bracket, one more negative, 3.4, close the bracket. Answer is 2.55. Energy of the photon is 2.55 electron volt. B is the correct answer. Atom is a tiny, hard, indestructible sphere. This model is the model in the time of Isaac Newton, in the time of Isaac Newton. The two problems with blah blah model were it predicted an unstable atom and it couldn't explain spectral lines, atomic spectra. This is the Rutherford's model. The idea of which of these scientists of the quantum jump between energy levels provides an explanation for auroras borealis, which is northern lights. Idea of which of the scientists of the quantum jump between energy levels provides an explanation for aurora borealis. So Bohr model explained that. Bohr model explained the northern lights. Question number 11. An electron in a hydrogen atom drops an energy level of E5 to energy level of E2. What is the energy of the emitted photon? We know again. Energy of the photon is equal to initial energy level in here, which is 5, to final energy level, which is 2. Fifth energy level is negative 0.544 minus of the equation, one more minus for the second energy level, 3.4. So use the calculator, negative 0.554 minus bracket, one more minus 3.4, close the bracket. Answer is 2.86 electron volt, which is the 2.856. And question number 12. The visible spectrum of hydrogen consists of how many spectral lines? So transition 2 n is equal to 2 consists of 4 spectral lines, which is the visible spectrum of hydrogen atom. In the blah blah model of the atom, electrons are embedded in a spherical volume of positive charge like seeds in the watermelon. This is Thomson's model. Question number 14. An electron in a hydrogen atom drops from E6 to E2. What is the energy of this emitted photon? Again, it's similar to the previous questions. Energy of photon is equal to initial energy level, which is E6, minus final energy level, which is E2, according to this question. Negative 0.378 is the initial energy level, minus of the equation, minus of the second energy level, 3.4 is the value. So use the calculator, negative 0.378, negative bracket, negative 3.4, close the bracket. Answer is 3.022 electron volt, which is B. Question number 15. And then electron energy microvapor drops from energy level of E3 to E2. What is the energy of the emitted photon? Again, same. Energy of photon is equal to initial energy level E3 to final energy level E2. So 4.86 minus E2, 4.66. So 4.86 minus 4.66, which is 0.2. 0.2 electron volt is the energy of photon. Question number 16. This diagram represents energy levels of hydrogen atom. If an electron jumps from one energy level shown in the diagram to another energy level, E, a photon is released with the frequency of this 6.9 times 10 to the power 14 Hertz. Which line represents the emission of photon? So which represents this emission? We will find this first, second, third, or fourth. First, we should calculate the energy of the photon, and then after that, we should check which energy separation between which energy levels is equal to that one. Let's calculate like energy of the photon in electron volts. E is equal to H times F. So H is 6.63 times 10 to the power of negative 34 multiplied by F, 6.9 times 10 to the power of 14. Let's calculate this. 6.63 times 10 to the power of negative 34 times 6.9 times 10 to the power of 14. Answer is, in electron volt, is equal to 4.57 times 10 to the power of negative 19 joule. But we should calculate energy in electron volt because all the given energies are electron volt in here. Energy of the photon in electron volt is joule divided by joule, which is 4.57 times 10 to the power negative 19 divided by 1.6 times 10 to the power of negative 19 divided by 1.6 times, bracket divided by bracket, 1.6 times 10 to the power of negative 19, close the bracket. Answer is 2.86 electron volts. So now which jump is almost equal to 2.8? It's normally it's 2.859, but we can round it to 2.6. Now one by one, let's check that. First, we should know that it's impossible such a transition 2.86 electron volt between 6 and 2, 6 and 5, 6 and 4, 6 and 3, not possible. So transition to n is equal to 2 can make such a big number. So we will check it is from 6 to 2 or 5 to 2 or 4 to 2 or 3 to 2, one by one. We'll check them. Let's check 6 to 2 first. And first transition 6 to 2. So it's going to be, energy of the photon is going to be E6 minus E2. So E6 is negative 0.378 minus E2 is negative 3.4. So let's check it. Negative 0.378 minus bracket 1 more minus 3.4, close the bracket. Answer is 3.022. So as you see, this is greater than 2.86. So this is the correct answer. Second transition line, let's check this. It is 5 to 2. Energy of the photon is going to be E5 minus E2. E5 is negative 0.544 minus E2 negative 3.4. So let's do it now. Negative 0.544 minus bracket 1 more minus 3.4, close the bracket. Yes, this is 2.856 electron volt. So as you see, the numbers are matching each other. So this is the second transition. So C is the correct answer in here.